Alright, today we're going to talk about one of the applications of exponential functions, and that is compound interest. It's one of the two types of interest, mainly simple interest and compound interest. And with compound interest, put simply, you just gain interest on your interest. Okay. A couple things that we need to know about, like the principal. The principal is the original amount invested or put away to save. Okay. It also refers to the original amount. If you borrow money, it also is called the principal. Okay. And compound interest has a formula associated with it. It looks like this: A, the amount, equals P times 1 plus the interest rate R divided by N, which is the number of times compounded, to the NT power. The P is the principal, and then R is the rate, N is the number of times compounded, and T is time in years. Okay. So compounding periods, how long do they wait before they compound your interest? Well, they could do it annually, which is 1 time a year. They could do it quarterly, which is 4 times per year. Most commonly, monthly, obviously 12 times a year. And not quite as common, but more common than the others, is daily, which is 365 times per year. Some accounts do that. So let's look at an example using our compound interest formula that we just learned. Suppose $4,000 was invested at 5% interest for 3 years, compounded monthly. What is the investment worth at the end of the 3 years? Well, first we figure out what all these numbers are. 4,000 is our principal, that's going to be P. 5%, that's R, but we write it as a decimal, so 0.05. 3 years, that's T. And compounded monthly, that means N is 12. So if I have my compound interest formula, I'm going to plug those things in. 4,000, 1 plus 0.05 divided by 12 to the 12 times 3 power. And when we plug that in, to our calculator, 4,000 and 1 plus 0.05 divided by 12 to the 12 times 3 power. That gives us a total of $46.4588. So that equals $4,645.88. That's what they would be worth 3 years later. Okay? So the rate, why is it divided by 12? Well, because the rate is annual. So it's annually 5%. And they don't want to give you they're not going to give you the entire 5% every month. That would be a monthly rate. So they divide by 12, and that's what you're getting actually every month, is a much smaller percentage based on that. Okay? And then we multiply by 12 here because there are 12 months and in a year, and we have 3 years, so 12 times 3 is 36 months in 3 years. Now let's do another example. Suppose $2,500 was invested at 2.8% for 6 years, compounded daily. What is the investment worth at the end of the 6 years? Well, if you want to pause and try this on your own, you can come back and see how you did. And here we go. P is 2,500 then. Okay, P is 2,500. Put it there. The rate then, R, is 0.028. T is 6 and N is 365. So I'm going to plug that in. A equals 2,500. 1 plus 0.028 divided by 365 to the 365 times 6 power. If we again plug that into our handy dandy calculator, we're going to end up with 2957.32, 2,957.32 cents. Okay. And one last example. Suppose you want to invest money today so that in 5 years' time you will have $10,000 available. How much will you have to invest at 3% compounded monthly to make this happen? Well, let's then look at that. We still have our formula. A equals P, 1 plus R divided by N to the NT power. And so now the 10,000 does not represent P, that's A. So if we plug in our known values, we have 10,000 equals P, 1 plus 0.03 is our rate, 3%, divided by compounded monthly, so 12, to the 12 times 5 power. Now we have to solve this for P, so we're going to divide both sides by this monstrosity here. And so we'd have 10,000 divided by 1 plus 0.03 divided by 12. No, sorry. Yep, no, 12 is right. To the 12 times 5 power. Okay, and once again, we put that into our calculator. Now it's 10,000 divided by, parentheses, 1 plus 0.03 divided by 12 to the 12 times 5 power, and we get 8608.69. So we'd have to invest $8,608.69, and that would give us 10,000 at the end of 5 years.